Airships are among the most intriguing flying machines in the history of aviation. Once they embodied the triumph of engineering thought, and today they are once again striving for that role. But what do we really know about them? What were airships fueled with in the past? How are they controlled in the air today? And what laws govern these giants of the sky? Welcome to the podcast about airships in plain language, dedicated to the New Generation Airships project. And as always, your host is Gennady Babanin. Aerostats, which are also widely known as airships, are essentially controllable flying machines that are able to stay aloft thanks to the significant lifting force of a low-density gas contained within their expansive envelope. A truly distinguishing feature of these airships is the crucial presence of powerful engines and sophisticated control systems, which allow them to precisely travel along a specifically set course. This sets them apart from uncontrolled balloons. Airships are generally classified according to their structural features and are divided into three types. The first type is the non-rigid or blimps, which are the simplest in design. They do not have a rigid frame and maintain their shape due to the pressure of gas inside the envelope. They are lightweight and maneuverable but have their own limitations. The first airships from the Aeronova company, such as Nova 01, Nova 2 and Nova 8, will also be built using a non-rigid design. The next type is the semi-rigid airship. They combine a flexible envelope with a rigid keel beam. This design provides both stability and a strong base for attaching the gondola with engines, combining the advantages of both non-rigid and rigid types. The third type is the rigid airship. They have a metal framework, an outer envelope and internal gas cells. This makes it possible to build airships of truly large sizes. The well-known Hindenburg was a rigid type airship. As part of the New Generation Airships project, we also plan to build rigid airships, and the first of them will be the Nova 35. This will be the first and smallest airship of this type produced by Aeronova. The main components of an airship include a durable envelope, a framework, gas cylinders, a gondola for the crew and passengers, as well as a power plant. Today, the envelope can be skillfully made from polyester or nylon, as well as from even stronger fabrics such as Vectran, Aramid or Kevlar. These advanced materials inherently provide high strength and excellent wear resistance. To ensure airtightness and protect against solar radiation and moisture, polyurethane films and other special coatings are applied to it. The gondola is a suspended cabin specifically designed to accommodate pilots, passengers, cargo, and all other necessary equipment. The traditional shape of the airship is not just an attractive image but the result of engineering calculations in the field of aerodynamics. Most airships have an elongated cigar-shaped form, which allows them to minimize air resistance and ensure stability during flight. Other airship configurations also exist, although they are much less common, and these are mostly experimental versions such as spherical, Formidian and flattened shapes. The shape of an airship is determined by the laws of flight physics. The better its aerodynamics, the less energy is required to overcome air resistance. That is why airship shapes are carefully designed during the development stage. The choice of a specific type of airship is determined by its intended purpose, whether it is for passenger transport, military operations, or scientific research. The specifications of an aerostat are directly influenced by its size, structural features, and the type of gas used. For example, 1 cubic meter of helium can lift about 1 kilogram of cargo, so volume is a key parameter. The larger the internal volume of the envelope, the greater the lifting force generated. As an example, we can mention the often cited Hindenburg, which had a volume of approximately 200,000 cubic meters. This allowed it to carry about 100 tons of useful payload, whether passengers or other types of cargo. Historically, the very first airships owe their existence to hydrogen, the lightest gas in the universe. Its specific lifting force is 1.2 kilograms per cubic meter, surpassing all alternatives and making the devices highly efficient. Hydrogen is easily produced by electrolysis from water or by the reaction of acids with metals, which makes it cheap and accessible. Its only fatal flaw is its extreme flammability. The slightest spark, static electricity, or a lightning strike could cause a disaster. The tragedy of the Hindenburg airship became the most vivid and tragic example, symbolizing the end of the era of passenger airships. The search for a much safer alternative ultimately led to helium. This inert gas does not burn and does not support combustion, which drastically increases flight safety. In terms of its physical properties, it is inferior to hydrogen in lifting capacity, about 1 kilogram per cubic meter compared to 1.2 kilograms per cubic meter for hydrogen. But at the same time, it retains its key advantage, lightness. After the tragic Hindenburg disaster, helium subsequently became the de facto and indeed the only permissible lifting gas for all manned airships. All modern airships that we know today, those used for advertising, surveillance and scientific research, exclusively utilize helium. Of course, there are other potential alternatives such as heated air, flammable methane, or even still futuristic vacuum airship concepts that are being explored. However, all these alternative solutions either fall significantly short of helium and hydrogen in their essential physical properties or are currently unfeasible for various technical reasons. For example, in the case of vacuum airships, it's impossible to create an envelope that is both light enough and strong enough. The forward movement of airships themselves is provided by engines. In modern models, these are electric or hybrid engines, while in historical ones they were gasoline-powered. Propellers generate thrust, while rudders, horizontal, vertical, and thrust vector control systems allow the airship to change course, altitude, and maintain its position over a designated point. The development of modern technologies is contributing to the revival of airships as an environmentally friendly and efficient mode of transportation for the future. So, if you're interested in the history of aviation, the physics of flight, or innovations in transportation, you're in the right place. Airships are truly a fascinating subject, combining technology, science, and the romance of the open skies. And it's great that you're already interested in aeronautics, because in the coming years this mode of transport will take a leading position in the market. How to become a participant in the New Generation Airships project and personally influence the development of eco-technologies and aviation, we explain via the links in the description and in every new episode of the podcast. Well, that's all for now. Thank you all for watching this video to the end. Leave your comments and we'll see you in the next episodes. Goodbye, everyone.